So let us discuss this problem. So this says we have a Bayer loop A, B, C, D. So this is A, P, C, D. So this Bayer loop we have. And this carries a current I. So through this Bayer, D to A to B, C to B to C, C to D, there is a current as shown in the figure. And we have an infinite Bayer here. And their current goes inside. So at this point current, I have a Bayer, infinitely long Bayer, and that goes inside. So due to this system, we have to find what is the net force on this loop. So first part of the question says calculate the net force on the loop. So this is a quite interesting problem. So let us try to do this one. So I am making the diagram again. So I have here, this is my infinitely long wire. Now from here I have something like this. This side also I have to go. And there is a this kind of system you have, and then you have something like this. Are you getting? And the current in this wire is this direction, in this wire this direction, and in this wire this is the direction of current. We have to calculate the total force. So force is what? So let us calculate total force. So we will calculate force part by part. So this is your part A, this is your part B, this is C, this is D. So now let us calculate force on AB. So what will be this force? You see, due to this wire, what is the direction of B? So current is going inward. So if I want to find direction of B, so B will be in this direction. Are you getting? Also radially. So this is the direction of B. It's a radial. Are you getting or not? So this will, magnetic field lines will follow something of this kind of path. So this is the B. So radial lines. Now B and delta are both are basically anti-parallel to each other. So this case delta L cross B. So even if we have some I, delta and B both are anti-parallel to each other, so force is 0 in this case. Are you getting? Now let us say find force on CD. Again this is again 0, because in this case again uniform. So magnetic field lines is this, and wire length delta L is also this. So delta and B making 0 degree angle. So this is again I into delta L cross B. So this is again 0. So this force is again 0. Now let us consider the force on BC. This is important. So finding the force on BC is slightly tricky. How will find? You see what is happening due to this wire. This magnetic field for this point, magnetic field at this point is changing. So magnetic field is changing. So if I want to find force on BC, that is I delta L cross B. So I am interested in force on BC. So I am interested in I delta L cross B. So I have to take care of the B also. What is the value of B at this point? So let us say at this point, if I consider this point, that is a x distance from the origin. So this distance is x. So let us say this distance from origin is x. And this is a small portion of the bar. If I say this is dx, so this a small portion is dx. So let us say this a small portion has a width dx. Are you getting or not? So now I can say, so this is a small portion dx. So I can say force is equals to I delta L cross B, and delta L is dx, and B and dx are perpendicular. So this is the direction of B, that is radially, and this is going, this is tangentially. Basically you see, if you circle, so this is a tangentially. So delta and B and perpendicular. So delta L is perpendicular to B, I know. So basically delta L and B are perpendicular. So I into delta L into B. And what is the value of B? That is mu naught I by 2 pi r. So this wire carries current, let us say I1, and this wire carries current I2. So for this I have to write I2. For this, mu naught I1 divided by 2 pi x. So this will be the value of force I delta L cross B. What is the direction of force? You see delta L is this direction. This is the direction of delta L, B to C, and B is in this direction. So if you see, if you follow the right hand rule, so if you come from, so this is the direction of delta L, and this is the direction of B. Are you getting or not? So this is the direction of B. So if you go from delta L to B, your thumb will point in. So that is direction of delta L cross B is inward. So let me write this force is inward or inside the plane of paper. So this is inward. Now if I calculate the total force, I have to simply integrate this one. So now I can say total force on BC, total force F total on BC. This will be simply integration of this. So mu naught I1 I2 is a constant. I can take this at outside, mu naught I1 I2, and this divided by 2 pi. 2 pi is again constant, so you will have simply dx by x. Are you getting or not? Let us say what is the limit. So this is, let us say up to this point you have R1 and up to this point you have R2. So this is OA length, let us say OB length is R1, and let us say OC length is R2. So I have to integrate from R1 to R2. So if I integrate this from R1 to R2, so I will have mu naught I1 I2 by 2 pi ln x, and ln x, that is ln R2 divided by R1. Are you getting or not? So this is the force. Now what do you think about force on CD? So this is force on CD, we have said 0. Force on AD, again the magnitude will be same. Magnitude wise this person and this person is equivalent. What is the sign? Now force on DC, so delta L is this direction and B is in this direction. So what is delta L cross B? So if find delta L cross B, so that is again up. So let us try to see what is the delta L cross B. So force on AD. So I am interested in force on AD. Magnitude wise the same. Magnitude will be mu naught I1 I2 divided by 2 pi and ln R2 by R1. So you will have ln R2 divided by R1. Now I have to find direction. So this is the direction of AD, is this delta L is this side. So delta L is what? So this is my delta L. So this is the direction of delta L, and B is what? So B is this. So what is delta L cross B? So delta L cross B. So this is coming up. Are you getting or not? So this is outward. So this is outward. So you see, what is the total force on the loop? You see, this force will add, and one is inward, another is outward. So and the two forces are 0. So F total now I know. So this is F total. This is equals to 0. Now what is torque? What is torque on the loop? So now I am interested in torque on the loop. Torque on loop. So the total force is 0. What is the torque? How we will proceed to find torque? So that is an easy task. Torque is nothing but force times distance, that is F cross R. Now you can see I have the situation something like this. I can represent the same situation. So now I have my wire is something like this. So I have this is my loop. So this is the loop we have, and in this loop there is a force that is acting. At this point there is a force acting, and this point there is a force inward. So this force is inward, and at this point I can imagine this force act from the center of mass of this bar. There is a midpoint, and this force is outward. So this is F, and this force is again F. Now if somehow I find what is the distance between these 2 points, we can calculate the magnitude of the force. Okay, so let us find the perpendicular distance. So we have to make again. So what we have? So we have something like this. So this is the loop you have. So let us make slightly curved. So this is the original loop you have. So this is the midpoint. So this is the midpoint of the loop. or midline, the axis you can see. Now this is the another part. Now let us say this loop makes an angle alpha to the center. So this is the center of this loop. This side again you have, so this angle. Now this can be solved only if this angle is given. So let us say this angle is alpha and this symmetry, so this angle is again alpha. So now we can find what is the distance. So in this case you have the current force is inward and here you have force is upward. So basically we can calculate what is the distance between these 2 points. So we can calculate perpendicular distance between 2 forces. Are you getting or not? So this is a perpendicular. Let us call this point as O, this point as M, and this point is N. Are you getting or not? So this is point N. And we can calculate only if this distance is given. So let us say the question also gives you OM and this distance is R0. So now we can calculate Mn. So what is Mn? So let us write sine alpha. So I will have sine alpha is equals to Mn divided by, so Mn divided by, so this is R0. So this is Mn divided by OM. OM is nothing but R0. So let us write OM. This is nothing but Mn divided by R0. So this means what is Mn? So I have Mn is equals to R0 sine alpha. Are you getting? So this is the distance. So you have Mn is equals to R0 sine alpha. So now I can calculate torque. So torque is basically force into distance because this is a case of couple. So this force and this force forms a couple. So force into distance, that will give you the couple. So torque. So force is how much? We have already calculated, that is mu naught I1 I2 by 2 pi. So this is mu naught I1 I2 divided by 2 pi. And then you have ln R2 by R1. So this is the force. And now this should be multiplied by distance. Are you getting or not? So this should be multiplied by distance. What should be the distance? Mn is basically R0 sine alpha. I need this distance MP. So MP is nothing but 2 times Mn, and that is 2 R0 sine alpha. So let us write torque. So this is mu naught I1 I2 divided by 2 pi ln R2 by R1, and this distance is 2 R0 sine alpha. Are you getting or not? So this distance is 2 R0 sine alpha. So this is the torque. If somebody asks what this torque is trying to do, so what you will say? So let us try to figure out what this torque is trying to do. So this is the one point, their force is basically acting inward. So on the top point you have the force that is acting in the inward direction, and on the bottom point force is acting in the outward direction. So this is the force direction. So at this point you have an inward force, at this point you have an outward force. Are you getting or not? So what this torque is trying to do? So if you have axis of rotation is this. So this is the axis of rotation, O and O dash. So this torque is trying to rotate this loop something like this. Are you getting or not? So try to see what this torque is trying to do something like this. So this torque is trying to rotate about this axis. This is the axis of rotation. O dash is axis of rotation. So this torque is trying to rotate this loop along O dash. And what about this? A clockwise or anti-clockwise? So if I ask this is a clockwise or anti-clockwise, this is a clockwise. You see, since we have 1, 2, 3. So here you have 12 o'clock. 1, 2, 3, 4, 5, 6. Again 12 o'clock. So this is the clockwise. So what this torque is trying to do? So clockwise torque. So you have a clockwise torque. And this torque is basically trying to rotate the loop. So clockwise torque tries to rotate the loop, tries to rotate the loop, simple, tries to rotate the loop.